Difference between electric field on an insulating sphere and electric field on a conducting sphere. Alright, let's look at this. If I have, for example, this to be an insulator, or let me start with a conductor. If this is a conductor, let's say I have plus charge here, plus charge here, plus charge, plus charge. Let's say I have charges on this surface. Or, yes, even if I have it this way, however it is you want to look at it. For the fact that this is a conductor, you will notice that from chemistry in secondary school, they tell you that if you have a proton, there's a negative, 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 negative. So there will be magnetized. Eh? The effect will cancel out, making this electrically neutral. The same thing with this, 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 the same thing with this. So the same thing with this. So what it goes to mean is that if it's a conductor, automatically it is trying to move out to locate negative. Negative. So the charges does not spread inside. You understand it? But if you remember, that's the that time that we did uh what's it called? Metallic bonding, something like that. Yes. Yes, and metalloids, sorry. You will notice that if, for example, this is a charge, 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 charge. Because this is an insulator, and we know that insulators are not good, they are not good conductors of electricity. So because of that, instead of it looking for charge that it will go and transfer to, because you know that protons move out, that is positive, we normally say it move out, but you know that in the indirect sense we normally say that it's the electrical one that moves faster, because we know that the mass of electron is lesser than that of proton. So instead of this moving out, because it is not charged, what will happen is that it will settle inside. So the charges, there will be many charges, that is, all of its charges will be packed inside. So that is now what I want you to understand. The principle, the concept I want you to understand is that once you hear an insulating sphere or an insulating anything or an insulator, take it that the charges are spread inside. Because if you remember when we started, I told you that there is no electric field inside a conductor. No electric field inside a conductor. Reason being that if you have that particular charge, the charge itself tends to move out of itself. So it tends to go and locate another one. So if that be the case, when it is an insulator, you can now say that okay, there will be electric field on the inside. So you need to know this. So this one is for insulator. Insulator. So you can have, for insulator, you can have electric field on the inside. On the inside and outside of the area or sphere. That is for, there's so much air here. That's why my book is bent, you understand. One, for a conductor, you only have, you have the electric field on the outside. That is E. Electric field on the inside is 0. So only outside. So that is why you normally see us when we say, for example, they come and tell you a conducting sphere has this, has that. You come and see, maybe they tell you a conducting line of charge. They come and put this. Once you hear conducting, the Gaussian surface can be outside. You see it? So it can happen outside only. So when you are drawing that Gaussian surface that we normally draw, it can happen outside only. But if you hear an insulating surface or an insulating line of charge or whatever, just know that if you have this now as it is here, it will spread. So the electric field can be inside and outside. So you can have the Gaussian surface inside. If it's a cylinder you are using, you can have it inside. You can also have it outside if it's a circle, however it is. So just note these two things. And that is the difference between an insulating sphere or an insulating medium and a conducting medium. So note it. Thank you. In our next class, we'll now deal with problems associated with electric flux, Gauss law, and charge density.